then I would say let's start. So welcome everyone to the seventh lecture in requirements engineering, covering requirements quality assurance, which together with the lecture on requirements management will conclude the basic lecture series, in which both will be introduced in a more nutshell format, because both requirements quality assurance and requirements management are meant to support the interfaces between requirements engineering and the surrounding development, but also management activities in the software development life cycle. So what we will be doing during those lectures is to concentrate more on how we can accommodate those interfaces from within requirements engineering, so along the actual engineering of our requirements, but all these aspects that are more related to the activities beyond, or what is beyond the scope of requirements engineering, we will leave rather open, because they are subject to other disciplines and also other courses. Now, as always, let's start again by recapitulating what we learned in the past lectures, this time in plural. So if looking back on the engineering lectures we had in requirements engineering, we have learned how to use this artifact-based requirements engineering reference model, and how to specify the content items, starting with the context layer, where we capture the stakeholders representing who is interested in the software system, and their goals representing why they are interested in the software system, and using both as a basis to infer the requirements, covering functional requirements to specify the user visible external black box behavior of a software system, and non-functional requirements covering also a variety of different content items, ranging from quality properties of a software system, but also other non-functional requirements affecting more implementation constraints or constraints on the actual software development process model. Now, what is left open from here? As my father tended to say always, if you do something, do it well, which for us means that once we have a first draft of our requirement specification, we need to make sure that it's of sufficient quality so that the others working with this requirement specification can do it properly, which is addressed by a systematic quality assurance in requirements engineering, in which reflects the goals of today's lecture unit. So what is in scope of today? We want to learn why quality assurance is so important to requirements engineering, and what the basic principles and concepts and terms are that are related to requirements quality assurance. And we want to set this into context to the MDIA approach, taking two perspectives, one which we will learn as constructive quality assurance, and the other one which is known as analytical quality assurance. So as mentioned earlier, here we will be focusing on those aspects that are more relevant from within the perspective of requirements engineering, but also those aspects that are relevant in the context of your project, covering not only what we do in requirements engineering, but also beyond requirements engineering, for example, in context of testing, and more generally speaking, quality management and quality assurance. So let's directly start. Both goals are reflected in two topic items for today. We want to first discuss the relevance and the related terminology and requirements quality assurance, before then taking more the perspective on the MDIA approach and how it relates to those related terms. Let's directly start with the relevance and the terminology. And here I would like to start again with a very brief recapitulation, looking back on what we learned in the last 4 lectures. And I don't want to talk as much about the general notion and core activities of requirements engineering itself, as much as I would like to briefly recapitulate on the very basic principles of artifact orientation and artifact-based requirements engineering. As you will very likely remember, we said at the very beginning of the course that especially requirements engineering, in contrast to other disciplines, requires a maximum of flexibility and precision. We need flexibility because we are at the very beginning of a software development project, and many things are not yet clear. See, we don't even know who the stakeholders are, what the needs might be, and how this might affect the general way of working. We don't even know which specific classes of requirements we might get, and how to elicit them, how to classify, how to refine them. And artifact orientation is one way to abstract from this specific way of working and concentrating on the results. And we said also that we require a maximum of precision in the results, because the majority of the problems we face in software development are in one form or the other rooted in insufficient requirements, very often reflected in vague, fuzzy, and non-measurable requirements. Now, an artifact-based requirements engineering accommodates both. We abstract from the way of working, and we give a clear guidance on how to specify the contents of a requirement specification in a what we call seamless manner. We know that the content model propagates how to specify stakeholder models, for example, what parts of a goal model are, and how these relate to the elements in a requirement specification, for example, how or what basic modeling concepts to include when specifying functional requirements. Now, another characteristic of these artifact-based approaches is that we leave open not only the way of working, but also the representation techniques, so the description techniques and the notations we may use to specify the content items. And this is of particular importance because, as we have also learned, the primary purpose of a requirement specification is communication. And the requirement specifications need to be understood not only by the engineers, but also by the stakeholders. And many of these stakeholders have skills in their areas, but maybe not as much in technical areas, which is also the primary reason why we basically use, in most of the cases, natural language to specify our requirements. And one such example for a natural language specification of functional requirements in the usage model is given by user stories. We have spoken about those user stories in context of the lecture on functional requirements. Now, imagine you specify such a user story, for example, in context of the development of a social media platform. And one such user story could say that as a user, taking again the black box perspective on my system under consideration, as a user, I can log in to delete my posts so that only I have control over my content. Now imagine that you specify the requirements and then you follow the textbook description. At some point, you would like to make sure that these requirements are valid. So what you do is you validate the requirements, which is a form of quality assurance. So what we do here is we check the correctness of this requirement by running maybe another workshop and asking the stakeholders, is this requirement correct? So your users can only delete posts when logged in. Everyone nods, yes, this is correct. We throw it at the solution engineers and they develop an application. We lean back and get something back where this requirement is fulfilled in terms of you have to log in order to delete posts, but this is pretty much what you can do. And obviously this is not what the end users, the stakeholders might have had in mind. Now, I know very well that this is a bad joke, and this might sound a little bit like a dad joke, but believe me, this is not too far-fetched. And many things can go wrong because of miscommunication and misunderstandings. Now, the key takeaway here is essentially this: even if we have an artifact-based reference model that guides the specification of, at least to some extent, measurable and testable results, this doesn't prevent us from making mistakes. And this doesn't prevent us from introducing what we call quality defects. Technically speaking, from a more syntactic perspective, the requirement we specified was correct because it was to some extent testable, it was measurable, and this is what we want to achieve by our reference model. But it is still not properly understood, at least the same way, by all the involved stakeholders, which brings me to the notion of more pragmatic quality. So the pragmatic quality was low. We will learn in a second what we mean by that. Now, all of this gives rise to do a proper quality assurance in requirements engineering and to have a requirements engineering of high quality. But what does high quality mean in requirements engineering, and what is part of it? So maybe we address this question more as a rhetoric question, because whatever we say now is correct and incorrect. So as we have learned in context of non-functional requirements, the general notion of quality is very multifaceted. So requirements engineering quality describes the degree to which requirements engineering tasks efficiently capture all relevant stakeholder goals and requirements correctly for an effective development. Now, if looking back at the example, was it efficient? Well, in a way, it was at least fast. So this is what we tend to do when using user stories. It's a lightweight approach to specify functional requirement. So we could argue that it was, at least to some extent, efficient. Were the requirements relevant? It seemed so. So we went into a validation workshop. Everyone agreed, yes, this is the requirement. We need that. So it was relevant. Was it correct? We thought so, at least to some extent. It was correct, but maybe not at all. And was it effective, the development? Well, if you want to say so, it was effective in delivering a software solution that solved a wrong problem. So it was a wrong software, but this was at least effective. So you see already here that same as with quality requirements, also here the notion of requirements engineering quality is very, very multifaceted, surrounding by a variety of influencing factors that all influence the quality of our approach. So typically, same as with the general notion of software quality, also here we take the perspective on two things. Number one being the actual process, the way of working, and number two being the outcome of that process, so the artifacts. And both are also somehow related to each other. So I can, but just to give you one example, I can specify the perfect requirement specification that clearly reflects excellently written requirements, all of them being measurable, all of them being very, very detailed. But if it takes me 2 years to specify those requirements, then we might think that it's not of a high value. So remember at the very first lecture when we spoke about the prejudice in requirements engineering, but one form of prejudice was that the customer doesn't pay to talk about problems, but to get solutions. At the same time, however, I can write my requirements very fast, very lightweight, in low budget, maybe only focusing on user stories, but they still can be wrong. So think of the consequences of solution orientation. So this also cannot be the case. One of the consequences of this way of thinking is that most of the quality assurance techniques typically focus on the quality of the artifacts, because at the very end, this is what matters most. Another reason is also measuring the quality of the process is very, very difficult, if not impossible. So at the very end, whenever we speak about quality assurance, we concentrate on the quality of the artifacts, simply because this is what is the primary scope of our engineering activities. But now here comes the key question. What does quality of artifacts mean? Now, also here we have different facets and different perspectives we can take. In requirements engineering in particular, we consider 3 different facets. Number 1 being the syntactic quality, number 2, the semantic quality, and number 3, the what we call pragmatic quality. Now, syntactic quality describes the extent to which the requirements meet language criteria. In our case, when using a reference model like MDIA, we describe with syntactic quality the extent to which the requirements we specify reflect the concept model. So are all elements proposed by MDIA reflected in what we specify in a project? So do all requirements, for example, have a unique identifier? Do all user stories describe a specific action that an end user intends to do? In our example, the syntactic quality was high because we specified the functional requirements following that reference model. Now, the semantic quality describes the extent to which the requirements cover the intended system and domain. So in terms of correctness, do the requirements properly reflect the problems and the needs of the stakeholders? So in our example, we are not sure if it's really high or low, but you will see in a second. The pragmatic quality describes the extent to which the requirements are equally understood by all stakeholders. So in our example we had right now, the pragmatic quality was particularly low. And one thing that you can see here also, at least indirectly, is that all these three facets, they relate to each other and they influence each other. So in our case, the pragmatic quality is low, which means by definition that we cannot really tell if the semantic quality is high or low. It is rather low. So even if the requirement would be correct in the perspective of one stakeholder, if not all stakeholders share the same understanding of what we have specified, it cannot be correct, at least as per definition. And the other way around, if the syntactic quality is low, so for example, if requirements remain vague or non-measurable, abstract, or if they are missing some parts in the description, we cannot tell if the semantic quality is high or low, or if the pragmatic quality is high or low. This affects very much our way of measuring the quality. Now, the strong dependency to the syntactic quality is also the primary reason why most of the available quality assurance techniques focus on measuring what we call the syntactic quality. Another reason I would argue, at least, is that it tends to be, I don't want to say easy, but easier, because to measure the syntactic quality, we can take clear reference models like a checklist. I can take, for example, the MDIA model, and just compare what I have specified with what the MDIA model says. And I can really say, is it conformant? Is one conformant to the other? And this is how I check the syntactic quality. Now, that being said, if I talk about requirements engineering quality assurance, I need to consider all three perspectives, all three facets related to the quality of the artifacts. Which brings me to quality assurance in requirements engineering. Now, quality assurance in requirements engineering describes the application of systematic approaches to identify quality defects in the syntactic, semantic, and pragmatic quality. So to identify quality defects and to ensure that the requirements artifacts are of sufficiently high quality. Now, sufficiently high quality is key here to understand, because there is no such thing as a universal, external, normative gold standard for quality. This holds not only for requirements engineering, but in principle for the whole software development lifecycle. There's no such thing as an oracle that tells me this is of high quality and this is of bad quality. Remember, requirements engineering, same as any other discipline, is always a means to an end, never a means in itself, which means that my understanding of quality is essentially characterized by the extent to which what I specify is fit for purpose, to which extent it fits my intention and my purpose. So, for example, imagine that you specify everything up front to make sure that every single statement in your requirement specification is clearly understandable. If you consider now the project situation where you have an in-house development, where you are sitting all together, where you can communicate all the time, then this very high quality is good, but it might not be necessary. It might not be justified by the actual needs. Which reminds me of one example of a little story. A couple of years, 10 years ago, we had a very interesting academia industry collaboration, a project with a German car manufacturer. So I don't actually have to anonymize it, because in this story we have been the idiots and not them. So we had a very interesting collaboration with a car manufacturer, and back then we were playing with quality assurance techniques that we could automatize. So our idea was to use a tool to investigate quality defects and requirement specifications, especially in very, very large requirements specifications. And one particular focus we had was natural language defects back then. So what we could, for example, reveal with the tool were passive voice sentences, because they are meant to be bad, or inconsistencies in the requirements because they are meant to be bad. So what we did is we took a requirement specification of a project at this car manufacturer. We throw it at our tool, and we had a dashboard, and this dashboard was completely red because it showed a huge amount of different defects. And then when we opened the requirement specification, it was actually written in a very strong German dialect. Let me not say which dialect. It was a very strong dialect anyway. So we had then a workshop. We invited all the engineers to that workshop. We discussed with them the results and showed, hey, look, the quality of this requirement specification is very, very low. And then they asked why. And then we showed, yeah, because it is full of, dialectic phrases, and it is full of passive voice. And this is bad. And, and then they asked us, but why? And this question was excellent. They asked us why. And we told them, yeah, because, literature says so. Literature says that if you write passive voice sentences, you will have problems in the inference of a proper architecture model. If you write passive voice sentences, you won't be able to infer a proper data model. And if you write passive sentences, you won't be able to infer proper test cases, acceptance test cases. And they looked at each other and looked at us and said, but we don't have these problems. And this is true. This was an in-house development project. They were all sitting together. They knew each other for many, many years. Many of them were friends for 20 years. And it was for them very easy that if they didn't understand something in the requirement specification, just to grab the phone and call the respective owner of the requirements engineer responsible for the requirement, and just ask them. So you see, quality is always something that needs to be addressing a specific purpose, a specific context need, which means for us that if I set up a quality assurance for requirements engineering, it needs to accommodate my project situation and my project needs. Now, back from this excursion, So exactly. So when I need to set up my quality assurance, it needs to fit my particularities or the particularities of my project. And I need to consider essentially two things. I need to make first a selection of the quality criteria that are relevant for my project. Not only the quality criteria, but also how I would like to measure them. For example, what do I mean by correctness, and how do I want to check the correctness? Or what do I mean by completeness or measurability, accessibility, and so on? The list of quality criteria is potentially very long. And the second thing I need to establish is my quality assurance approach, my quality assurance process. And here I need to distinguish between constructive quality assurance and analytical quality assurance. And both the criteria and the way I do the quality assurance, we explain next at the example of MDIA. Now, MDIA, if I have my artifact-centric perspective on the key outcomes of my requirements engineering process, I can take two perspectives on them, one internal perspective and an external perspective. And the same holds for quality assurance. The internal perspective is what we call the constructive quality assurance. Constructive quality assurance means quality assurance during the construction of the artifacts. This is what we do as part of requirements engineering. And this holds, of course, for any other discipline as well. Analytical quality assurance refers to an external, independent perspective that I can take on my artifacts. And independence is here key. Very often in your projects, you might have roles that are not associated at all with requirements engineering. You might even have roles that are not associated at all with your whole development project. Very often this is done by external suppliers, by third parties. So we have an internal perspective and the external perspective. In terms of quality assurance, in terms of constructive quality assurance that I do within requirements engineering, I consider to do everything that I can do upfront. So anything that I can do upfront to ensure best practices in my work and in my outcome of that work. In terms of analytical quality assurance, I have this external perspective. And here I do everything that I can do after the fact to evaluate if the work done meets selected quality criteria. Now I have different criteria that I can apply differently in both constructive and analytical quality assurance. The constructive quality assurance typically focuses more on syntactic quality because this is what we can do having a more external reference. But many of the quality facets that I have from my artifacts, like the pragmatic quality, but especially the semantic quality, I cannot do externally. This is something that I have to do internally. It is us, the requirements engineers, that talk to the stakeholders. It is us, the requirements engineers, that gain through requirements engineering insights into the domain and a proper understanding of the particularities of that domain, so that only we can at least approximate the extent to which the requirements we specify are sufficiently correct and sufficiently complete. Now, as I mentioned earlier, the analytical quality assurance is more external, independent, and the constructive is more internal, what we do upfront. And both are complementary, and both aim at checking whether we meet certain quality criteria, so that we might, let's say, pass to the next stage, so that we can use the outcome, the artifacts, in other surrounding software engineering disciplines or phases. And what we do this as part of what we call a quality gate, which brings me from the what to the when. So a quality gate defines essentially, let's call it a point in time when I employ my quality assurance techniques. In terms of MDIA, we have, as you will very well remember, only one way of defining a workflow, and only one way of defining a time variant for the outcomes, which is given by the milestones. Now, every artifact in MDIA has two milestones. One of the milestones is always the entry point into the artifact, and one is the, let's call it, exit point out of the artifact. So in the case of the requirement specification, the entry milestone is the system vision defined, which means that I define a point in time where I feel confident enough, because I have a broad overview of my use cases, when I can specify the details of each use case in my subsequent activities. Now, the exit point defines a point in time where the overall requirement specification, the whole artifact, has been formally accepted, validated, which is associated with what we call the quality gates. And the quality gates, or these milestones, are the handshake between the constructive quality assurance and the analytical quality assurance. At this point, we see that everything that we could do upfront as requirements engineers has been done, and now it's time for the external quality assurance to make an independent last check before we give the requirement specification to the subsequent or surrounding development phases, at least in good faith. Let's put it this way. Now, as part of these quality gates, as I mentioned, I can employ different quality criteria, and the list is here potentially very, very long. Good for us is that in requirements engineering, we can rely on standards. One such standard is the IEEE recommended practice for software requirement specifications that defines a set of different quality criteria that I can rely on during not only my constructive, but also analytical quality assurance. But in terms of what we can do in terms of a constructive quality assurance, I have a set of criteria that are more in scope of individual requirements or sets of requirements, and others that are more in scope of whole artifacts, so that I can only check very late during my quality gate because I need a sufficient completeness. So for example, one such quality criteria is completeness. I cannot answer this one as long as I don't have a first draft of my requirement specification. Consistency describes, for example, the whether requirements are contradicting each other. When I start with my requirements engineering, and I might still have some high-level goals like usability and security, we may assume that there is a potential for conflict, but we do not yet really know until we don't have more detailed requirements related to security goals and related to usability goals. So this is the reason why we do this more at the end. Those quality criteria that focus more on individual artifacts, that focus more on sets of artifacts, is what we can do by construction on the fly. So for example, the correctness of the requirements, I can do multiple workshops after eliciting my requirements to check with the stakeholders to which extent these requirements are really valid. The precision is something I can do easily. It's a syntactic criteria referring to the syntactic quality. I can do this by comparing it or by following my artifact model. Accessibility is something that is very much related, of course, to the precision. I can always ask my question, especially for quality requirements, can I test it? This refers to the accessibility criteria. Changeability, prioritization, this is more, I think, self-explanatory here. Now, important is that we can use this standard to decide what to check. But to understand how to check it, we have different forms and ways of doing this. I can define different values. I can define different measures that I can apply to check this single quality criteria. And this is not in scope of this lecture unit. How we can do this in principle is in scope of the lab units, and how and which of the criteria might be important to the project and how we should do this specifically for those projects is in scope of the project Q&A session, which brings me already to the conclusion of this lecture unit. So we have a variety of possibilities to do a constructive quality assurance in requirements engineering. We have a variety of different quality criteria and different options of how to use those quality criteria. What I would like you to do is, once you meet this point in your project, put some thoughts into which quality criteria you deem particularly important and how you plan to apply these quality criteria. Brainstorm and let's discuss this in the hands-on sessions. And with this, I would like to conclude already the lecture on quality assurance. And thank you very much.